Here we go. Welcome, everybody. I would like to introduce Dr. Juan Lopez from UPAEP as our speaker for March in our Emerging Technology Research, Creativity Research speaker series. And one of the reasons why I wanted Dr. Lopez to be part of this is that 2 summers ago, I was at UPAEP as a visiting faculty, and they showed me their 3D printing lab, where they were doing a lot of work and a lot of research around how to integrate, how to print different parts and integrate them into the human body, sort of his biomedical engineering research. And one of the passions that we shared was really the idea of using emerging technologies to transform, regardless of whether a person is growing up in an environment where technology is available on a moment's notice, or they don't have any technology, these emerging technologies available. So I'd ask him to come in today and just share with us a little bit about his work, really focusing more on the transformative power of emerging technologies and sharing us with his work on 3D printing and how it has transformed healthcare in Mexico, the potential for it to do that. So, Dr. Lopez, welcome.
Thank you very much. Thank you, Doctor. Thank you, everybody that's there. I really appreciate this opportunity, and my door will always be open virtually, email or here in person if you ever get down to Mexico. So please just consider this a first point of contact for any of you. And we're ready to start?
Yeah, go ahead.
Excellent. So one of the big things that we have to do, and I think we have such a diverse background of people here, countries and experiences and lives, that you'll all immediately understand that a big part of understanding any kind of problem or solution to a problem, a big part of understanding why things are, you know, the epistemology behind something and not just the ontology behind it, is the context, right? This glass of water is out of context. I don't know, it almost feels right. Gravity's not working the same way there. But we don't have a broader context of what's going on. So we really can't understand what's happening here without understanding a context. So in this case, the work that I'm doing is in a particular context. Yours is going to be in a different one, right? So I'm just going to spend a little bit of time contextualizing what some of this work is and why it matters in this context, and hopefully you guys can extract some of those lessons for your various contexts as well. So globally, as far as Mexico and medical technology and all of this, you know, the global medical technology market is gigantic, right? $387 billion. Now, yeah, that's not even one Apple or one Google, but it's still an extremely large market. Okay, it's expected to have a 5% growth, pretty relatively steady for the next few years. And one of the issues that we have is here in Latin America, consumption far outstrips production. And when I say it far outstrips production, it's not that we're not manufacturing it, it's that which we manufacture is being exported to countries that are willing to pay more for the stuff that's manufactured more cheaply here. Okay, so the solution has been to then import technology to meet local needs. And obviously, whatever you manufacture here that you export and then re-import, there's going to be a significant cost factor associated with that. A little more locally, that means Mexico imports, this is an optimistic number by the federal government, Mexico imports 95% of its medical technology. And in that same report, they said of that which we've already spent money importing, 45% no longer works. So you don't have a local access, half of it is broken. This makes for a very precarious situation for people in their healthcare, right? The local market is about $2.5 billion, and we export about $4.5 billion worth of technology, and 90% of that customer base is just the United States. I'm gonna, you know, how many of you would actually believe that 2.5 billion would let us procure about half of what we export. And I would assume very few of you would believe that that's anywhere even close to the number. So we've got this relatively large market, but our local community is at a high disadvantage because even though we've built it here, we've made it here, we have the people, the personnel, the skills, and the factories that are able to meet FDA standards. We're not able to purchase that stuff locally. It still has to get shipped out and then purchased again at a much higher price. And this is a direct and severe impact to the population. There's another context, and that's the context of research. Okay, I was glad to hear that we have somebody from South Korea in the room. In the last year and a half, South Korea has been a big talking point for me. And you obviously have a lot more experience with South Korea than I do. With me, it's just by the numbers. But a good point of reference and comparison is in the 1980s, South Korea and Mexico were very similar on a whole bunch of different measures and indicators, whether it came to GDP, poverty, corruption, just all sorts of indicators. Mexico and South Korea were very much peer countries, all in that same little ballpark in the graphs and indicators for growth over time. And yet South Korea has radically transformed itself into being the number 4 innovator on the planet as a country. Okay, so whenever I talk about these things, people often think that I'm spreading kind of a hopeless message. We're hopelessly behind. We're 95% import. How are we going to possibly fix this? And one of my answers has been South Korea. All right, I mean, you can, in a generation, turn around the prospects of a country when you come together as a country and decide we're going to do some things differently. Now, no offense, I'm almost glad. I think I didn't go to some schools or universities. University of Seoul has to be just a complex study and work-life balance environment for some people. I'm not saying these things come free or without a cost, but it can be done. Okay. What happened in the 1980s, which is about when Mexico and South Korea start taking these very different pathways in their national evolutions, Mexico realized it had an innovation and brain drain problem, and a pretty severe one. So they devised a system to deal with the situation. They decided we'll recognize somebody that's called a national researcher and give them a fellowship. And this fellowship would be a monthly, tax-free, non-tax reportable. You don't even report this on your taxes. It doesn't change your income as far as the government is concerned. That could double or triple a researcher's salary, depending on where they were. Very attractive. It seems like a great deal, right? I mean, you're doing research for the country, you're generating innovation, the country's going to reward you with a stipend to stay here and continue being a superstar. So what happened? It became a permanent tenure review process. For any of the faculty present there, imagine if you came up for tenure every 3 or 4 years for the rest of your career. Forever. Until the day you retire. It becomes about the only thing that these fellows are able to focus on. You know, the next review is coming up rather quickly and rather soon, and the indicators are rather bureaucratically skewed. Okay. So rather than being this wonderful contributor to keeping innovation in Mexico, it had quite the opposite effect. Now, there's a lot of people that would argue with me about that point, and a lot of those people are the ones receiving the fellowship. You know? This is an example of where throwing money at a problem is not necessarily the solution. Just taking wads of money and throwing it at a problem without having this more transcendent view of what you're trying to do is not necessarily going to fix it. From 1991 to 2019, the system has paid out between 400,000 and 500,000 years of fellowships. Okay? 500,000 years of research fellowships from 91 to 2019. From 91 to 2016, all universities in Mexico, and I'm not talking about just these researchers with fellowships, but all universities in Mexico produced little bit less than 3,000 patent applications. Completely, utterly, totally failed at creating this massive innovation. Last time I checked, I don't have updated numbers, but I mean, right now, from 2016 to today, Mexico's producing about 2,000 patents by Mexican. They're patent applications, not even awarded patents, a year. In South Korea, I think it's 400, 500,000. Okay? So that's about one patent application per educational institution in Mexico over the entire time period, and more than 160 years of fellowship paid to produce one patent application. Okay? Completely the opposite of what we'd want to do. Okay? We have not yet figured out a good pipeline between academy and industry. Okay? So this is the context in which you're having to come up with ways to be transformative with the use of technology, to show people that there's a different way that you can do things. This is a word that some people bandy about. I'm not sure how into the global concept, but the global and local combination. Well, there's another study that focuses on the world's medical technology and health biotechnologies. Only 1.2% of all that research from 2001 to 2015 came from a combined 6 countries in Latin America. Only 400 articles from Mexico were deemed of enough quality to be included in that survey. And this is a problem. This is a problem. We could spend all day talking about these indicators. In fact, I've given hours and hours and hours of conferences on this subject. I've almost gotten burned at the stake at a couple of these universities when I'm talking against the use of these really juicy fellowships. Okay, so we won't spend the rest of the day talking about it. But there's a major disconnect here. Okay, doctor, I am horrible with pronunciations. And I've gotten so used to the accents in Spanish. Where do I accent your name? Asino? Asino?
Asino.
Asino.
Yes.
I'll read it like I am in Spanish. You know, it's such a shortcut in Spanish to have the accent tell you and remind you every time you're reading something exactly where to put that emphasis. I apologize. So, you know, Dr. Asino has been here. He's met the students. He's met the faculty. He's worked with Dr. Criselin, who has won a UN prize, you know, from these sustainable development goals 2 years in a row with teams that she's worked with. You know, the talent is incredible. I've got incredibly talented students. I've got greatly talented peers. The faculty that works for me is amazing. People that work at other universities, my competition, everybody, there's an extreme amount of talent. And I know that there is more than enough talent to be a player on the global stage. Access to medical and health technologies is a universal necessity. And we need to do something to transform this non-presence into something transformative. And that's what we're working on in this program, okay? And hopefully a little bit about these lessons you can take and recontextualize into these different aspects and different problems that you're looking at, you know, and all this is to set the stage, all right? In this case, we're talking about a very limited set of emerging technology. Obviously, you guys have an entire conference series because it'll take hours and hours and hundreds of hours to go over this more comprehensively. So we're talking about emerging technologies in the world of medical technology, right? But medical technology is more than numbers, it's more than companies, it's more than indicators or papers, it's more than institutions and programs. Medical technology is people. Educational technology is people. Transportation technology is people. Food technology is people. You know, I think few of us are in this game for purely theoretical reasons. Thankfully, there are theoretical scientists out there, and we need them to transform, you know, their ideas into something practical 40 or 50 years later, and I appreciate all of those colleagues, but a lot of us are here because we understand that at the core of much of what we're doing is people. So whatever we're investing in, whatever we're working in, whatever we're seeking to transform, we're transforming the world for people, and that gives whatever we're doing a lot of weight. Okay. Medical technology is in service of people and plants and animals. I mean, I'm not trying to diminish any other aspect of it. It's designed to enhance, improve, relieve. It is fundamentally necessary anywhere in the world, in any community, in any culture, in any segment of people. Unfortunately, as happens with so many things, it's also something that can be divided into a can and can't on affordability and access. Okay? There's great technology. There's magnificent technology. Can it be found accessible to the vast majority of the world's population? You know, is it really something that's out there? And that can go for any of these technologies that we're talking about. Okay. Now, the exciting thing, and the reason that you guys have probably heard this a dozen times already, is that emerging technologies help change this potential imbalance and problem. They help democratize some of these things, bring them to more people, have them more accessible to the world. I'm going to start out with an example of where I got started. This was me in college. In my last year, this project got started, and then I stayed on as an advisor and a consultant for the next 2 or 3 years, helping them write grants and get the project going. And I have nothing to do with this project anymore, but it is where I got my feet wet and where I got my love for what we're doing. It's what I went to college and just got an engineering degree, no specifics, but it's what made me love biomedical engineering and continue. So they were looking at how to create a low-cost effective prosthetic. Okay, they were looking at communities where being able to walk to work is the difference between being able to, live or be completely destitute, right? So what can you do that's cheap, effective, can be done with few tools, and can be actually helpful to a local community? So they came up with a solution that required very few tools. I believe it's 4: a vacuum, a bandsaw, a drill press, and a Dremel. Those were the tools that you needed to give somebody the ability to walk again. Okay? They did a lot of testing, gait analysis, mechanical testing, etc. And they came up with this, this design. Okay? It started out as legs, Laterno Engineering Global Solutions, and then it became limbs, and now it's Limbs International, and I think the acronym has kind of been lost because the professor that founded this changed universities, so the word Laterno isn't even associated with it anymore. So what's going on with this design? Okay, it's relatively simple. It's got a fiberglass socket that all it requires is molding. Okay, so the trained person can then learn how to mold these sockets on patients when they're there getting fitted. And it's got a polycentric knee that's able to lock in place during part of the gait and release during part of the gait purely mechanically. No sensors, no electronics, no controls, nothing. And they spent a lot of time engineering the foot so that you could have energy return. Because one of the big downsides is having to provide all of the energy to the prosthetic, both to take your step and then to lift it back up to take the next one. So being able to have some kind of energy return was transformative. Okay? And they did a bunch of testing. Okay? They tested to the maximum usage load. They did dynamic fatigue, millions of cycles, impact, compression, torsion. Wanted to make sure that this would be a viable and functional prosthetic, as well as a lot of gait analysis, right? Making sure that it fit the biomechanics needs of people. Okay? Their goal was to create a prosthetic for under $100. And the first model was a prosthetic for $40. The average prosthetic in the United States ran $50,000 to $50,000 for the simple models. 50% of those prosthetics are abandoned because people simply do not become used to wearing the prosthetics. The numbers have improved greatly since this research was done back in 2000, 2001. But still, you know, 4 tools, $40, and able to train the people to build these prosthetics in a week or 2. That's transformative, right? CARE International and Mercy ships were given the design technology to do these, and now they go and they build these prosthetics wherever those ships dock. Okay. They've gone and done this in multiple countries around the world, and they've got probably at this point hundreds of patients that they've directly participated in, and possibly thousands that CARE and Mercy ships have done. $40. You know, it's quite a bit of difference if you can convince a company to give you $10,000 in donation, that'll build hundreds of prosthetics, versus $10,000 and that'll give me half of one. Right? So the impact to the communities that need it most was incredible. Now, this is done well before any of the emerging tech that we're going to be talking about now, but this is what sets the stage for me to know how much of an impact a little bit of ingenuity, a little bit of creativity can make to the world. I really, really miss our old university motto. The one that replaced it with, I don't think is nearly as great. And it used to be, faith brings us together, ingenuity sets us apart. That's what you're bringing to the table. Now it's something like in every classroom and in every workspace. Okay, but this sets the stage. This is my first real experience with advanced research and output, and we were undergrads competing with graduate schools. You know, we were able to go out there and make a difference in lives. So, you know, now, thanks to the lab and thanks to your space there, I'm sure most of you guys are at least somewhat familiar with or have used 3D printing. Yes, no, maybe, possibly, yeah. You know, this is, next 2 or 3 years, this question is going to be completely irrelevant. It's the answer is just going to be yes, I am familiar, or yes, I have used. Okay, but that is one of those emerging technologies that has been here to help change the world around us. Okay, I'm only going to play short clips from these. Can you see the video?
Yes.
Okay.
Should it be playing? The video is not playing right now.
It's not actually playing for you guys?
No. There we go.
There we go.
Let's go back to that. You see that joy? That joy is transformative. It still gets me every time that girl turns and looks at her brother and tells him, "I'm walking." Like that expressive, "I'm walking." She's got some 3D printed orthotics that they custom fit to help strengthen her ankles so that her weakened ankles under her medical condition, she could actually stand up and take a step with. Okay? Not very expensive, and yet extremely transformative. I'm sure you guys have seen prosthetics like this. Can you see the video?
Yep.
Two guys working out of a shed, delivering transformative medical technology to kids all over the world. This has grown into other kinds of networks. There are now other places. This is Team Unlimited. There's the Enable Network, etc. People can sign up and say, I've got a 3D printer. Let me know when there's somebody in my area that needs me to print off one of these for them. And you'll get, you'll get the files, you'll get the instructions, and in a single day, you can have a prosthetic ready for under $30. And again, we're talking about in a world where prosthetics can cost thousands, $30 in one day to change the life of somebody. And it's not just, people, right? There's the example of this cute little puppy. Tumor as big as her head. They 3D printed a scan of the dog's cranium and then custom molded this implant to replace the skull they were going to have to remove. Okay? Now, obviously, this technology is not just limited to dogs. I'm going to be talking about that here in a second. They're looking at Newcastle University. They're 3D printing corneas. They're not implantable yet, but they're in process. You can see the blue tinted one being held up there by the doctor on the left. And that's the team of researchers that are working on this process. So, this kind of technology has been transformative. It's been huge. And the question is, what do we do with this? Where do we go from here? How do we actually implement that? So I'm going to talk briefly. I know we're reaching the end of our presentation time here, but generating innovation, there's an excellent report that looked at what the 1,000 most innovative companies in the world are doing. Okay, sadly, there wasn't a single Mexican company on that list from 2007 to 2018, but we're here to change that. I'm here to change that with my students. Dr. Asino is there to change that with you guys, all right? Being able to make sure that innovation is something that's transformative and take these lessons and apply them even to the smallest scale project. Quickly, we can see where spending is projected to be in major industries around the world, and healthcare, computing and electronics, software and internet are going to be the top 3 players for a while yet, okay? And working innovatively is also transformative to the ability to make a difference, okay? The companies that were the best innovators far outperform the biggest spenders, okay? The top 10 spenders do not have the market share, the growth, the cap, and the ability that the biggest innovators do. Innovation and being able to bring that adequately to bear matters more than throwing money at the problem, okay? So the lessons that we have to apply to the work that we're doing and the work that some of my students have also been doing are these. Closely align your innovation strategy to what you want to do as an institution and a company, a startup, etc. Create that culture that permeates, and innovation requires a lot of failure and being willing to fail and fail and fail and fail, always taking lessons from those failures and continuing to grow on to the next thing. The upper management is highly involved in the innovation program, supporting it, being able to take those risks, supporting the people that are risk-taking, supporting the people that are failing, as long as they're learning from these failures and growing, and basing innovation on information directly from the end user. Again, like these kids that we saw in those videos, right? It doesn't matter to build something that just works technically. It has to be something that works with the people whose lives are going to be impacted by this. Rigorously select the projects that you're going to undertake. Perhaps it's just not the skill set, not the time, not the population, not the group with which this particular proposal will work. And most importantly, the most innovative companies from the 1,000, there's one additional link. They excel at those first 5 topics and are able to integrate them in a way that creates unique experiences. And that is something that is completely achievable by anybody that's working on these things. All right, we can focus on being this kind of space. And I don't care how much money you've got, how much, you know, technologies at your disposal, what country you're in, you can focus on being this kind of transformative innovator. So the final story, the local success story that comes with that is our student Diana here in our biomed lab. Okay, so she's working on these innovation goals. She's got a startup. She's been successful. She's a few weeks from completing her PhD, so she wasn't able to join us. She has a terrible, insufferable professor who's making her do a lot of edits and rewriting. And, you know, such a bad guy. And her work has already impacted lives. Her work has been used in over 30 surgeries, just in the process of completing her PhD. I'm extremely proud of the work that she's done. She's an extremely talented and creative individual who's going to leave me in the dustbin of history, and that's exactly what every professor wishes from their students. So what has she done? She's refined a workflow to incorporate much cheaper manufacturing technologies, such as standard, what most people think of as 3D printed, fused deposition modeling, into having cheaper, more effective scanners and open source software, along with a deeper knowledge of physiology, engineering, and years of experience to create personalized medicine. Okay? None of these things are new, right? By themselves, not one of those things is new or has never been seen before in the world. Most of those things have operated together on some level or another, but she has brought a workflow that makes this accessible and viable in a much less financially robust market like Mexico. Okay? By finding a variety of needs, she's built a startup. There's links to her website and Twitter and Instagram, and it's been a sustainable way to serve the community. And what do I mean by sustainable? All right. She realized that you can't build a company like this and focus only on those really hardcore, out there, fascinating problems. You also have to be able to do day-to-day work, right? And just make sure that your workflow has your company set up in such a way that when the emergency comes, you can apply all the same stuff to saving that life that you can for the day-to-day work, okay? So here's a couple of examples of the work that she's done. Some of it has been over at the University of Notre Dame. Now, being able to take medical images and create functional 3D models. The image on the left is from an adult foot, but the image on the right is from her own work, which is neonatal surgery, okay? What we can see on the left-hand side of the screen here is where those 30 types of surgeries have been involved. There are a lot of maxillofacial reconstruction surgeries. They can be from congenital defects, trauma, any kind of similar issues. And what she's giving is a tool that has a variety of uses. One of the important tools is communication and patient empowerment. Okay? Not a lot of patients can really understand a lot of medical imaging, CAT scans, MRIs. You know, a lot of this stuff ends up being just a little bit of a weird magic. And it's, I don't know, it looks like a bunch of gray blobs, but you're saying it's this, right? Actually taking a physical representation and putting it in the hands of the patient and the doctor allow them to have a more open and profound conversation. You know, this is an empowering conversation. This is what we're talking about. This is what we're attempting to do. This is where the problem is. What questions do you have about this procedure? And the second aspect is that it has given the surgeons an ability to pre-plan surgeries. You can pre-fit a lot of the plates and the things that you might be using to work on things. You can practice with your team. You can decide which materials are going to be flexible enough to fit your needs. And that's the kind of surgery that she does all of the time. On the right-hand side of the screen, you've got a heart with silicone aorta, okay? What she's done is she's developed a neonatal model for an esophageal problem that newborn babies can have. Now, these problems occur so rarely that no doctor is going to be an expert. No one hospital or group of hospitals is going to have enough of these cases for a doctor to be like, yep, I'm the top guy in the country. I can do this with my eyes closed. Newborn babies can't be stuck in an MRI machine. You can take 1 or 2 x-rays, and then you kind of have to best guess your way into what the surgery is going to be. So Diana teams up with the surgeons and takes a standard neonatal model and adjusts it and modifies it to the doctor's specifications. And that includes all the internal soft tissues, lungs, heart, aorta, esophagus, trachea, which she builds out of dissolvable materials like PDA. And then she coats them with different kinds of silicone to get the different kinds of thicknesses and textures and pliabilities, sticks them all inside of a skeleton and sticks that inside of an artificial skin. And then the doctor and his team can go in to the OR and practice the surgery and work out what they're going to do as a team before actually getting the baby. The maxillofacial surgery, she can turn around in a day. The full surgical practice model can be 2 or 3 days. And she can do it for 1/10, 1/20th of the cost, what it might be to go and have these things done. This is from one of the printers you didn't get to see, the new ones, Dr. Osino. And these are now resin models, right? And so this is instead of having to coat it in silicone, she's directly printing it in flexible resins, but it still seems like the silicone is going to be a much cheaper option, but at least this was an attempt, right? The outcomes are transformational. Work can be done in a fraction of the time. The costs are much lower, and the same technology can then be brought to bear to a whole host of issues, right? Access to technology is a life and death question. This might be a bummer, you know, but a few months ago I had to bury a family friend that had a tumor between the heart and the lungs. They weren't able to operate on it because the doctors couldn't get a good visualization. They didn't know exactly what they were getting into. It was just too complex of a surgery. I'm not saying Diana's work would have made that problem go away, but it would have at least been a fighting step in the right direction. We lost him, a 15-year-old kid, you know, simply because it was too difficult to visualize what it is we needed to do. So as we're looking at our future, at what's next, at what we have to do, we really have the choices to, you know, keep big, never grow, we're dominant, we don't need to change, or be transformational, right? So the questions that we have left are what do we do with these emerging technologies to change the world around us? Thank you.
Fantastic. Thank you. Okay. Anybody has any questions for Dr. Lopez?
I always love it when I'm so crystal clear that it generates no questions.
And thank you for your feedback, by the way, because we did end up buying a resin 3D printer as well.
Ah.
So we have been experimenting with that.
Yeah.
They're fun. They really are.
All right. Questions, feedback, comments?
So you have a team that help create the 3D objects, right? Because like different people, they have different kinds of needs. And like, do you have a lab or like?
So that would be the long-term goal, yeah. But no, all of these things that we talked about here today are just Diana, and her company is a company of one. Yeah, she's hoping to be a company of multiple to be able to deal with these different problems and different kinds of surgeries much more rapidly. but she's also trying to be prudent and not grow too quickly. You know, she's feeling the market. She's building those relationships with the doctors and the surgeons, and she's wanting to make sure that it's something that if she does open up to more people and more employees, it'll be a sustainable job rather than just something that's open for a few months and then she has to shut down. But yeah, the goal would be to have multiple people involved in this process and pipeline, like for the work from Diana. There are maybe 10 or 12 projects going on in the 3D printing lab right now, and they run the range from looking at drones to looking at these medical parts, but they're each independent projects.
Thank you. I used to work with the children with disability at schools in Thailand. I see that there's a lot of students that need help in different types, like some they don't have arms or legs. Or yeah, if we need help, like who can I contact with?
Well, thankfully, we've got Diana here, but like I said, there's also this worldwide network, right? There's LIMS International is with that university in, I think they're the University of Texas, El Paso, and they've got their headquarters there, and they're trying to operate in countries around the world. You've got the Enable Network, the Unlimited, LIMB, you know, the Unlimited Network. And these are companies that are trying to find ways to give these prosthetics to people in need for free, you know, or much more cheaply than they would any other way. One of the other things that these kinds of technologies are allowing is a destigmatization of these disabilities. You know, there's no kid that's sad to run around with an Iron Man fist. You know, it's the ability to customize and to take the stigma away from these devices and say, this is just something else that I need. You need glasses, and I need this thing. You know, it's a different version of life and living, and that also greatly increases inclusivity.
That's great. Thank you so much.
Absolutely.
Question for you. One of the things that we talk about in our lab is how do we decide what to print and for what purpose? So can you talk maybe a little bit about how do you address that in your lab? How do you decide, because 3D printing can be fun just for the sake of printing. So how do you decide what to print and for what purpose?
There's a variety of criteria that we use. One of them is, especially with eminently recyclable materials, we're a lot less picky and choosy. Instead of what we're building is a recycling pipeline. So a shredder, a remixer, a refuser, and something to create new filament from the rejects. So when it comes to that kind of material, what we choose to print is just whatever seems interesting that we'll know we'll be able to recycle later, because there's a lot of learning involved in fine-tuning the parameters. That's a really big difference between having a $2,000 or $3,000 machine and having $1 million machine. Right? Those $1 million 3D systems, set it and forget it machines are really set it and forget it. You don't have to worry about any of the parameters. You don't have to worry about the quality by mixing and matching, what you're choosing to do, speeds and temperatures and thicknesses and, all of these things that you end up having to worry about with these. They're not cheap, but definitely much more inexpensive printers. So there's a huge learning curve, and printing a bunch of stuff is about the only real way to get a feel for each machine. And each machine, we have 6 copies of machines in our lab, and each one is its own temperamental beast. That one will print ABS better, and this one will print PLA better, and that one doesn't like 3mm filaments, and this one only likes 1.75mm filaments. So it's printing a lot of a lot of everything, but generally with those materials that are recyclable, that we know we'll be able to do something with a little bit later. When it comes to things like the resin printer, you're a lot more choosy. There are things that you'll want to be very certain it's very nearly a complete model. So what we do is we now have 3 levels of printers. We have the FDM printers, those 6 printers that are lower quality, cheaper, and they run with cheaper filaments that can be recycled. It's almost anything. You know, test your idea, run your idea again, tweak the parameter, and as long as the printer's free, keep going. And then we have an Ultimaker, which is a much higher quality FDM printer, and that's to test the final stages of your design, make sure this is nearly production-ready design, and then you can go on to the resin printer for the showpiece, right? And that, you know, the resin is so much more expensive that we're only going to let you print something that's essentially already been through the ringer in those other cases. We also, it's a variety of ways that you fund the place, right? So we got funding, and so that students from 3 of our programs, whatever their personal research project is, the material there is available for them as part of their lab access. But anybody else that comes to visit the lab and wants to print a part, the way we became not choosy is that's fine, but you got to leave me almost as much material as you use. So, you know, if you're going to come in and use a couple 100 grams of material, bring a 400-gram spool. And so feel free, print your part, but, you know, the lab is going to acquire a little bit more material to do other work and research with later. So it's a balancing act of what ends up being the best way to go about it. And it's definitely, you get a lot more choosy the more expensive the materials, the less number of printers you have, the greater the amount of time demand there will be for the different printers. But it's definitely less choosy on the research end with the cheap printers, and then make sure that you actually know this is going to work by having done it already with those cheaper printers before I let you onto the expensive or high material cost ones.
He mentioned something here. I don't know. You mentioned something about recycling filament.
Mm-hmm.
So what do you do with that? So you reuse filament again?
For PLA especially, PLA is a much more reusable filament.
Okay.
You can grind it back up, you can re-extrude it, and generally what you need is simply to mix in some fresh PLA with every batch, and it'll vary, you know, so that's what we're experimenting with. Okay. How much fresh pellet PLA are you going to have to add to recycled PLA to have it be a functional material? And at the end of the day, we're not even that worried about how great that plastic quality will be, because if I'm recycling that plastic, then I can just use that cheaper plastic for the test prints, right? I don't care if it's going to be more brittle or if it's an ugly gray blobbish color because it's got 7 different colors mixed in. It's just my way to test my initial design and the way we go. Now that aspect is what our students are currently working on right now. We've got the grinding down. We have a large industrial grinder. We have a large injection molding machine that we can test some of the plastic melting parameters with. But we're really working with some chemistry professors and with some engineering students and professors to kind of fine-tune the way that kind of recycle process could work.
Thank you.
That's definitely an issue that we face here as well, about how to reuse some of the stuff and some of the health and environmental related.
Mm-hmm. There is I don't know if it's still on the market, there is an all-in-one machine. It was called the Protocycler. And it was a desktop machine with a hand-cranked grinder. And that really made it a lot cheaper. You didn't need a motor that would be able to chew through metal. That's what you got muscle and students for. Mm-hmm. And you could feed the old parts into the hand grinder, and the grinder would churn out little pellets. And then you could transfer that over to the new fuser and extruder. And again, these filaments will not be as high a quality as you get from a standard, commercial product. They're going to vary in diameter as they come out of that extruder. Typically in a commercial product, they're coming out of the extruder straight into a water bath. So that crystallizes the plastic at that specific diameter. So we're trying to explore, you know, the alternatives to get close to that without having to get an expensive process. But, you know, one of the things we just didn't do because of money, I think they're like $1,000, was get access to one of these protocyclers. And we figured it would be a good research project for students anyway, since we have a variety of departments. But there are solutions out there, and you can look them up. You know, if protocycler doesn't exist anymore, maybe somebody else is currently doing it. And there are extruders already, you know, like the Fill-Extruder and the Fill-A-Bot, and several of these other machines are out there to extrude plastic pellets into these filaments. The question is, what else do you do? You know, what other grinding process do you have? We're looking into the additives, right? Are there ways that we could make the additives a little friendlier? They're not that unfriendly. I think PLA is primarily glycerin as one of the fundamental additives to the lactic acid, but these are things that have to be explored, and waste is a major problem.
Well, probably have one more question. If anybody has a question. All right. Dr. Lopez, you were crystal clear. There is no questions. Thank you again for taking the time to share with us your work and the work that's coming out of your lab. I'm sure we're going to be continuing conversations. We have your emails here, so you might get some comments and questions at a later time. But
absolutely. Yep. And there's some editorial articles out there. I've included, you know, I'll get you a copy of this presentation. There's the references, and the page 2 and 3 references are just some selected editorials on related subjects. You know, research and innovation as transformation, catalysts, science in the university, et cetera, et cetera, et cetera. Okay, so there'll be some additional resources for you guys to look up there, and obviously get in touch with me if you'd like.
Thank you very much, and we hope you are free to join us for our next speaker next month, Professor Bali from American University in Cairo. She'll be sharing, talking on the same topic on emerging technologies from a global perspective. And thank you, everybody, for participating.
Great. Look forward to it.